All right, so we've already talked a little bit about the atom and the particles of the atom, a little bit about the history of the atom. So we've been focusing on the three major particles of the atom. So these include the electrons, neutrons, and protons. And today we're going to be talking about a few other things that you need to know about atoms. So we're going to start by talking about how do we know atoms exist? Well, we know that atoms exist because we have pictures of them. Now, these are not the type of pictures that you might take with your iPhone or with a digital camera. They're taken a bit differently, and we're going to talk about how they do that. But first, if you look on the left-hand side, you can see that the researchers have arranged the atoms in a particular order. And they kind of had fun with it, and you can see they made this sort of figure, and the figure has eyes and a mouth and arms and legs. And they just did this to have a little bit of fun. On the right-hand side, again, you can see what we might call a picture of these atoms, and you can see again that the researchers have arranged them in a particular way. And they've actually arranged them so that it reflects the name of the company they work for. So see if you can figure out exactly what company they work for. But again, we know that atoms exist because we have these pictures. Again, they're not quite like pictures that you and I might take. Instead, they use this like device here. This is called a scanning tunneling microscopy. And basically, it's not like a microscope, like you look through an eyepiece and you see, something that's really small that all of a sudden becomes visible. It's not like that. Instead, what it is a very, very sensitive machine that has a needle here at the end. And this needle is very, very sharp. You might even say it's one of the sharpest needles that we can possibly make. And as this needle passes over the atoms, you see on the right-hand side, these sort of ball structures here, these spheres, are representative of some of these atoms. And you see as this needle, this really sharp needle, travels over them, if it hits one of these atoms, it kind of makes a bump. So you see here there's actually two layers. There's a lower layer and there's an upper layer. So as the needle is sort of traveling along this, right along this lower layer here, when it hits this second layer, this sort of bump, what's going to happen is it's going to register this bump, and that will register, and a computer will interpret it, and it will, show it as, it'll show it as an atom. Now, of course, we can't see atoms like you can see things through a microscope because they're just so small. They're too small, and physics says that you just can't really see them simply because the wavelength of light is not long enough. It's actually too long to see these. But anyways, this is the best we can do, and we can sort of represent or sense these atoms using these sophisticated machines. Now, we talked about, again, the proton, the electrons, and the neutrons, and we said that the neutrons are the largest, the protons are just a bit smaller, and the electrons are by far smaller than both of those. So does that mean the electrons are the smallest particle that we know of? And the answer is no. We know that if we take a proton, we can actually split it into three smaller particles, and these particles are called quarks. And the same with the neutron. Of course, the quarks that make up a neutron are slightly different. So in addition to quarks, these are actually rather large particles, we have all kinds of other subatomic particles that you probably have never heard of. Things like muons and gluons and positrons and all kinds of strange, weird names. In fact, there's over 200 of these different subatomic particles. So one of the questions that these physicists have been trying to ask is, where does it end? If I take an electron and I can smash that and break it into smaller pieces, can I take those smaller pieces and smash those and make smaller pieces, and on and on and on? Where does it end? What is the smallest particle or the foundation of all matter? And the answer is we haven't really got there yet. We haven't really found this smallest thing or particle that makes up everything. So the jury's still out on that. Here is a representative of the 6 quarks that we know about. Now again, quarks make up neutrons and they make up protons. So you can see here there are 6 of them, and they don't really look like this, but a cartoonist has kind of drawn them to represent their name. And these are kind of odd names, and again, usually in science, when you discover something, you can kind of name it. So it sounds like they went a little bit crazy, and they probably had the reasons for naming them like this. I don't know what they are, but here you see that one of them they named it Up, the other is Charm, and the other one is Top. And then you see here they have one called Down, one called Strange, and one called Bottom. So these are just the names that they chose for the 6 neutrons. Or I should say, sorry, these 6 quarks. So again, these quarks, we can put them together in different combinations, and we can get different particles that are larger, like protons and like neutrons. So how do we find out all these particles? How do we find these quarks and these muons and these gluons and these positrons and all of these small particles that we have discovered over many, many years? Well, what they do is they actually take these and they actually take the atoms and they smash them together. And when they do this in what's called a particle accelerator. And here in this picture, this is a photograph, probably from a helicopter, looking down, and you can see that this sort of circular thing here, this is the actual particle accelerator. And it's actually probably several miles across. And what they do is they use magnets to propel these atoms around and around really, really fast until they actually get close to the speed of light. And they line them up just so they smash together. And then the scientists will look at the particles or the parts or the pieces of these atoms and try to figure out, what kind of properties do they have? What might they look like? What do they do? And so I kind of liken this as to, if you want to be a mechanic and you want to figure out how a car works, you could take 2 cars and you could make these 2 cars drive at 100 miles an hour each, and they would hit each other, and of course that would create a gigantic accident and pieces would go flying, and then you could then look at these pieces and try to figure out how a car works. Maybe not the best method, but really the only method we have right now. So you can think of these giant particle accelerators as racetracks for these subatomic particles, because they go really, really fast, and then again, as I said, they line them up just so to smash them together. So in a little bit, we'll actually watch a video about that, and you can see sort of how they actually go about that. So that's the end. Again, just a few more things that you need to know about about atoms. Make sure that after watching this video that you go and you fill in my wiki site and that you answer the questions.